What is a linear time invariant causal system? So in this course, basically the systems that we are studying, they are linear systems, they are time invariant systems, and they are causal systems. So what do I mean by that? Basically, a linear system follows superposition rule. That is, if you have an input x1 that is producing an output y1 from a system, then if you multiply the input x1 by any constant, any gain, the output will be multiplied by the same constant value or same gain. Now if you add two inputs, let's say a1 x1 plus a2 x2 to produce an input signal of x3, let's say, then the output will also be the combination of the individual outputs. So whatever output is produced by a1 x1, let's say a1 y1, and whatever output is produced by a2 x2, let's say a2 y2. So if you're combining these two signals at the input, then the output signals should also be combined, and the output is going to be y3, which will be a1 y1 plus a2 y2, which is the basic superposition rule from circuit analysis as we have discussed. So all linear systems follow the superposition principle. What is time invariance? Time invariance means that if you are delaying a signal, input signal, the output signal will be delayed by the same time. Or if you are advancing an input signal, then output signal will be advanced by the same time. As simple as that. So if instead of sending your input signal at t is equal to 0, you send your input signal at t is equal to 4 or n is equal to 4, the output signal will also be delayed by n is equal to 4. Or if you are sending an input signal early, instead of at n is equal to 0, you are sending the input signal at before 0, let's say at -4, n is equal to -4, then the output signal will also be advanced. That is, instead instead of being generated at n is equal to 0, y will be generated at n is equal to -4. So that's time invariance. Whatever delay or advance you are producing in the input signal, the same delay or advance is going to be produced in the output signal. What are causal systems? Basically, causal system concept is that if you are not sending the input, the output should not be generated. That is, you should not have a prediction model that if x will be this, then output will be this. Your model depends upon if input is present, then output is generated. So basically, if input is not present, the output should not be generated. Or in other words, the output should not depend on any advanced value of x, that the value that is yet to arrive. The output should not depend on that value. The advanced value of x means that the value that is on the left side of 0, n is equal to 0, and we write that as xn plus n naught. The one that is delayed value, or that has already arrived and passed, those values are on the right side of 0, and we represent them by xn minus n naught. So causal system, basically they don't depend on the values that are yet to be arrived. That depends only on the value that have already arrived, whether the value is the input or the value is of the output. So output can also depend on the past samples of the output, and of course current input and past samples of the input, but no past sample of the input that are yet to arrive, or no past sample of the output that will be generated in the future. So the current value should not depend on that, and those systems are causal systems. So I'm giving you a bunch of examples over here. You can go over them. I'm not going to go line by line, but they are pretty straightforward, and you should be able to understand them once you go over them. And if you won't understand them, definitely we can discuss these examples as well.